So my name is Claudia Hernández. I'm from Mexico. I work for this company called OutZero, and I'm a digital nomad. I love traveling. I'm very excited to be in Brazil. This is my first time, so thank you very much for having me here today. Woo! So I guess one of the main things that you're thinking when you are reading the title of this talk is, what is this talk even about? What's the deal with how to sort your socks using JavaScript? Like, what's going on with this girl? So if you want a little bit of context as to why I named this talk this way, let me show you the first title that I had in mind. So it's Computer Science 101, Intro to Computational Complexity, the Sorting Problem. Of course, at the time, I thought it was like a very clever title and that everyone would be into my talk. And then I realized it was a little bit boring, so I had to change the title. And afterwards, I read this article, and I was like, yeah, maybe sorting your socks with JavaScript could be a thing. And I want to ask you a question. How many of you come from a computer science background? How many of you study algorithms, data structure at school? Okay, like almost half of you, more or less. So actually, the purpose of this talk, or what I really wanted to achieve with this talk, is I want to explain some very basic computer science concepts in the world of algorithms, sorting algorithms, and try to make it as easy as possible for people that didn't study computer science. So let's start. I'm always worried that this talk might be a little bit boring to people, so I try to spice it up a little bit. So I'm going to leave you with this question. What does a pile of dirty socks, Napoleon Bonaparte, and Romanian folk dance have in common? If you want to know the answer to this question, just keep being awake, follow along, and you'll notice by the end of the talk. So computational complexity, that's the thing that I wrote in the first title. So what's computational complexity? Basically, it's just the study of all the possible algorithms that can solve a problem. But this is a sorting talk. So what is a sorting algorithm? A sorting algorithm is an algorithm that sorts elements of a list according to a certain order. The most commonly used orders are numerical and lexicographical. Just keep this in mind, it's really important. So this is a sorting talk, but this is a JavaScript conference, so of course, let's talk about the array sort function in JavaScript. And this is a very basic example. We have an array with numbers. We have a 33, a 2, a 98, 25, and a 4. And then we call JavaScript sort function. And of course, JavaScript gives us back this amazing answer. 2, 25, 33, 4, 98. Because of course, according to JavaScript, 25 and 33 are smaller than 4, right? JavaScript is crazy, right? So what is actually happening in this case? What we're missing is that JavaScript is actually doing lexicographical sorting. So normally what we will do is give a compare function to the sort function in order to make this sorting. But if we don't, elements are sorted by converting them to strings and then comparing those strings according to their Unicode code point value. So an example of this is, imagine we have these two arrays. We have the first one, a colors array with red and blue. We call the sort function. And basically what JavaScript is doing is sorting these elements alphabetically. So then we have blue coming before red, and that just makes sense. But what happens if we have a numerical array with an 80 and a 9? For JavaScript, this will be the exact same thing as if the 80 and the 9 were strings, because JavaScript is just converting the number back to string. And if you're noticing, 80 has a Unicode code point value of 56 and 48, and 9 is 5700. So you notice that JavaScript is not that crazy. It actually makes sense. 80 is lexicographically smaller than 9. So going to our previous example, 2, 25, 33, 4, and 98. So 25 and 33 are indeed lexicographically less than 4. So as I told you, JavaScript is not that weird. We just really need to know how it works. So what happens if we actually want to do something like this? Emojis actually have Unicode code point values, so you can also kind of sort emojis. And you can even combine everything, like the second array with numbers, emojis, and strings, because at the end of the day, if you don't supply this compare function, JavaScript is just going to convert everything to strings and try to sort those strings out. So what have we been doing most of the times when you're actually trying to sort numbers numerically. Because I guess when you have a numerical array, you want to sort it numerically, right? Not lexicographically. So we provide this compare function, as we have done all of the time. And we can finally have our sorted array, right? With 2, 4, 25, 33, 98 correctly as we want it in the first place. So this is very basic. I imagine most of you have already sorted an array in JavaScript before. But here comes the million-dollar question, something that I kept thinking about and that I couldn't sleep until I actually found the answer. So have you ever wondered which is the algorithm used behind the native sort function? Is it only me? Like, don't I have a life or something? So the actual answer to this question is that the ECMAScript standard doesn't really impose a certain algorithm to be used. What this means is that every JavaScript engine is allowed to use any algorithm they want. So how does this matter? Why does this matter, and how it looks like? The good news is that most of the JavaScript engines are open source, and you can actually see the code on the internet. So that's exactly what I did. I looked around, I did some research, and I'm going to show you the results. So this is the source code for SpiderMonkey, the JavaScript engine behind Firefox. If you're noticing, the actual implementation of the algorithm that they're using is merge sort. So what I really like about reading source code is checking out the comments, because you can learn a lot about the thinking behind these implementations. So in this one in particular, we have this comment that says, this sort is stable, sequence of equal elements is preserved. So the concept of stability is something that I'm going to be explaining later, but just keep in mind that SpiderMonkey uses merge sort, which is a stable sort. And the second comment says, apply insertion sort to small chunks to reduce the number of merge passes needed, which basically is just saying that for smaller arrays, this implementation is using insertion sort, which I'm going to be explaining about later. So what about V8? V8 is using an implementation of quicksort. And just like SpiderMonkey, they're also using insertion sort for smaller arrays because it's more performant. What about Nitro, the one behind Safari? Nitro is using an implementation of merge sort. And finally, Chakra is using an implementation of quicksort. So basically, what you're getting the idea that in the most famous JavaScript engines, we have a combination of insertion sort for smaller arrays, quicksort, and merge sort. So let's talk about sorting algorithms, because this is a sorting talk. What is stability? I told you I was going to explain this. And basically, stability is just a stable sort is one in which equivalent elements retain the relative position after sorting. I really like this picture because it makes it easier to explain. So basically, imagine that we have this set of cards. We have a 7 of spades, a 5 of hearts, 2 of hearts, and 5 of spades. And you notice that we have two values that are the same. We have a 5 of hearts and 5 of spades. In a stable algorithm, the algorithm is going to respect the original positions of the elements. So you might notice that the 5 of hearts comes before the 7 of spades. So once it makes the sorting, the 5 of hearts still remains in the same position before the 5 of spades. And in a not stable algorithm, the algorithm won't respect that. And you can either preserve the same positions, or maybe it will switch, but you will never be certain that the sorting that was before, the order that was before the sorting, is going to be preserved. And now let's talk about the 3 algorithms that I was talking about. And this is like the hardcore computer science part of the talk. So just, I hope you have coffee and that you're with me. Just, it's going to take a few minutes. Just bear with me. And the first one is insertion sort. And the way insertion sort, I told you it's really performant for small arrays, because it actually it searches sequentially through the array, and it starts comparing each element against each other and seeing which one is smaller than the other. It's really difficult to explain in words, so I have this small video that will make it easier to visualize. So let's say we start in the beginning of the array, and it's just comparing against every element in a sequential manner. And imagine this is just a for loop. Imagine if you had like 1,000 elements, 1,000,000 elements. It will take a lot of time and a lot of memory to actually be able to go through all of the arrays. So this is really good for small ones. And I hope you're getting the idea. So what does this look like in JavaScript? So this is the implementation of the insertion sort algorithm using JavaScript. And I won't go really into details about this implementation, but I want to highlight some things. As I mentioned earlier, in order to implement this algorithm, you need a for loop to be able to go through all of the elements. And if you're noticing, there is nothing weird going on in this implementation. It's just two simple for loops that is just comparing every element against each other and then just switching accordingly. So nothing weird, very easy to implement. This is something that you can implement in your code base very easily. Now, if I strip all of the comments and all of the new lines, this implementation actually takes only 10 lines of code. With 10 lines of code, you can have your own insertion sort function in JavaScript. So for the people who have studied computer science, maybe you remember this concept out of your courses, the divide and conquer concept. So this comes from, it's inspired in Napoleon Bonaparte, which basically they say that in order to be able to defeat its enemies, what Napoleon will do is he will divide its enemy into halves, and then he will attack each half independently. Because it's way easier to defeat a 500 army than a 1,000 army, right? So how does this translate to computer science? In the case of merge sort, imagine you have an array, and following this inspired tactic of Napoleon, basically what merge sort will do is it will divide the array into halves, and then recursively it would all continue dividing those subarrays into halves, until you end up with a one element array. Because a one element array is already sorted, right? Like there's nothing to compare against. And the merge sort function algorithm is called merge because once you have all of these subarrays, you will have to merge them back together in order to have your final big sorted array. This, it's really difficult to explain in words. I hope the picture is helpful to visualize. But then again, I have a video to make it easier to understand. Oops. So as I mentioned, this starts by just dividing the array into halves, continues dividing those arrays into halves, recursively continues doing that until you have one element arrays, and then the merge thing happens. It's just comparing each element against each other, and it's bringing them back together. So this is how merge sort looks. And what is a JavaScript implementation? So in order to implement this algorithm in JavaScript, you only need two functions, a merge sort function and a merge function that is going to combine back those arrays. So then again, these slides are going to be available afterwards. You can see into detail how this implementation actually is. But what I really wanted to show is that then again, there is nothing weird going on. We have two variables, a left variable and a right variable, which is basically just storing the right part of the array and the left part of the array. And then we're giving those subarrays to this merge function that we have afterwards. And as you might notice, the merge function is calling the merge function. So the only weird thing going on is maybe a little bit of recursion, but that's it. There is nothing weird going on. It's really easy to implement. What does the merge function look like? Then again, we just have a while loop and some if condition, and basically what this is doing is the while loop is going through all of the elements of the array, and then it's just comparing the elements in one array against the elements of the other array. And then it's just storing the smallest element into a result array. And as you might notice at the end, this function is just returning a result array with all of these elements sorted. If I strip all of the comments of both functions and all of the new lines, implementing merge sort with JavaScript only takes 23 lines of code, both functions, which is not a lot. And finally, we have quicksort. And quicksort is also similar, it is also inspiring this concept of divide and conquer. And the way quicksort would work is you will select a pivot element out of your array. A pivot element is just like a random element that you will choose. And then what the algorithm will do is it will put all of the elements of the array that are smaller to that pivot to the left, and all of the elements that are bigger to that element to the right. I'm going to show a video again to make this easier to understand. So in this case, the pivot element is the number 3. And basically what the algorithm will do is it will just put pointers in the beginning and the end of the array. It will compare those elements and just swap them according if they should be to the right or to the left of that pivot element. Once the algorithm finishes putting the elements either to the right or to the left, you will end up with 2 subarrays. And it will recursively continue sorting this way by choosing a new pivot and swapping the elements and then having more subarrays to sort from. How does this look in JavaScript? So here we have the quick sort function. And as you might notice, we have only a few conditions, and we're also calling recursively the function. The most interesting part of this implementation is the partition function. And basically what this function is doing, it's only having 3 while loops, and it's putting pointers to the beginning and to the end of the array, and it's just continuously going and checking each element and comparing if it's smaller or bigger than the pivot element that is stored in the pivot variable. This is very, very difficult to explain in a few minutes. You can see this later. But the main highlights of the implementations that I just showed you is that they are really, they're easy to implement. They don't have any fancy, weird data structure. The weirdest is maybe a little bit of recursion, but most of it's just for loops, while loops, and a few conditions. I didn't implement those algorithms. These algorithms have been studied by a lot of really intelligent people. So basically what I did is I saw some pseudocode out of computer science books, and I just translated this into JavaScript. So if you are interested, you can always look up these books and try translating it yourself. So then again, if I strip all of the comments, if I strip all of the new lines, this is the longest one, but this implementation only takes 31 lines of code. And basically what you can also do is you can even extend the prototype array and use this function as if they were almost native. So you can have your own merge sort function, quick sort function, and insertion function. And at this point, you're probably thinking, like, why should I even care about all of these things? Why should I care about making my own sorting function when there is already a shiny, cool one in JavaScript made by really cool people in C++ and blah, blah, so why should I care? And that's a very good question. The first reason that I can think of is because of design strategies. And I want to ask a question now. How many of you have debugged your code by commenting chunks of your code? And like you're commenting, and checking, like, no? Just 2 people? So this is unconsciously, you're doing the divide and conquer method. So you're just like trying to divide the code and see where the bug actually is. And this is a tweet from Dan Abramov saying how he was debugging CSS code by doing this technique, just commenting chunks and seeing where the bug was. This is the same concept behind git bisect start, just a binary search. The second reason you might be interested in implementing your own algorithm is because of stability. And this is from the MDN docs, and it says the native sort function is not necessarily stable. So what does this look like in an actual example? Let's imagine that we have the organizers of BrazilJS made an array with all of the speakers that are right now in the conference. Of course, the ages are not real, right? Because we don't have 6-year-old speakers right now. So all of these speakers are sorted alphabetically by last name. And you may notice that some of the speakers have the same age. So what we will normally do is provide a compare function and try to sort them by age. Imagine that the organizers also want to sort them by age. So what will happen if we do this in V8, which is using a quicksort implementation, and quicksort is not stable. So what this will look like is for the speakers that have the same age, the alphabetical order that was before is completely lost. So instead of having Adam Baldwin in the beginning, like he was before, he's just somewhere in between, and then we have Monica Len first, and there is me, Matthias Vine. So basically you notice that the alphabetical order is completely lost. It's not stable. What will happen with Nitro? Nitro is using merge sort, which is a stable algorithm. So for the speakers with the same age, you will notice that the order is preserved. So if you need to make sure that your data is the same across all of your applications, perhaps you may want to try implement your own stable sorting algorithm if you want to make sure that all of the answers and all of the answers is the same across your applications. And perhaps the most important reason you might really want to implement your own algorithms in JavaScript is because of performance. Because believe it or not, your own self-made JavaScript sorting functions can be faster than the native one. And if you don't believe me, just follow me along. So if you were not sleeping, maybe you noticed when I was showing the source code for V8 and Nitro that the implementation is actually written in JavaScript itself. So what is this? Is this some sort of JavaScript inception? And kinda, but in computer science, this is actually called self-hosting, which is implementing parts of a language in that very language itself. But shouldn't that be slow? So the thing is that arrays in JavaScript have methods like for each, map, reduce, and of course sorting, the topic of this talk. And what you know is that all of these methods uses callbacks. So every time you go through an element, this callback is called. So you have to iterate through all over the list, invoking the callback, and the execution has to switch between compiled C++ and interpreted JavaScript. This context switch is expensive. So by staying in the same execution context within the same language, we can gain a little bit of performance. So that's why you might want to stay within JavaScript. So this is a summary. So SpiderMonkey is not self-hosted, V8 is, Nitro is, and Chakra is. But if this is not enough enough for you, let's do some benchmarking. So basically what I did is I compared the native sort function against the self-implemented functions that I just showed you against different element arrays that are with numbers that are randomly generated. So this was tested in Chrome, so in Quicksort. And for the first one, it's a 10-element array. And as you might notice, I mentioned earlier that insertion sort is really good for small arrays. And my self-made insertion sort function is faster than the native sort function. So what happens with 100 elements? With 100 elements, insertion sort is still faster. My own one, the one that I just showed you, 10 lines of code, this is faster than the native one. With 1,000 elements, insertion sort is still faster than the native one. And what happens with 100,000 elements? As you might notice, insertion sort is no longer the fastest one, but Quicksort took the lead. And now Quicksort is faster, still faster than the native one. What happens with 1,000,000 elements? So with 1,000,000 elements, my computer crashed. So yeah, insertion sort couldn't deal with it. So for the next examples, I took away insertion sort. So with 1,000,000 elements, Quicksort was still faster. And I mean, at this point, I think you're getting the idea of what I'm trying to say. So with 10 million elements, Quicksort was faster than the native function. So at this point, now you're all experts in sorting algorithms, right? This is not a real certificate, but almost like. And I guess what I really wanted to say is that this talk is not about telling you guys to just start implementing your own algorithms and just stop using the native sort one. It's about choosing battles. It's about knowing when is good to use your own or when to choose the native one. So it's up to you to try to see your different use cases and check if this is useful or not. Either when you're sorting on the front end or if you're sorting in the back end with Node, just make sure that if it's important or not to actually be spending time implementing your own ones. If you're more interested in this topic, I recommend some books. This is the books that I search in order to implement these algorithms. The first one is the Algorithm Design Manual, a Bible for coding interviews, really good. And the second one, Foundations of Algorithms. Now, if you remember the question I said way in the beginning, like what does a pile of dirty socks, Napoleon, and Romanian folk dance have in common. You might notice that I already mentioned the socks. I already mentioned Napoleon. But this is it. If you're more into visual and into videos, for some weird reason, there is videos of Romanian folk dance and Hungarian folk dance explaining how the sorting algorithms works. So you can check that. And if you are into reading, I also made an article in a list apart about this exact talk with all of the code, with all of the explanations and examples. And if you are into that, you can read it. And that's all from me. Obrigada. I hope you really liked it. And if you have any questions, you can look for me later, and I'll be gladly answering them. So thank you.